Hey everyone, welcome to This Explainer. Today, we're diving headfirst into something totally invisible, yet absolutely critical to our survival, the air we breathe. We're going to look at the microscopic threats lurking in our atmosphere right now, and the incredibly advanced technology that is literally racing to predict them. We're combining findings from two fascinating studies to give you the full picture.
Look at this. Air pollution is believed to kill more people worldwide than AIDS, malaria, breast cancer, or TB. That is a staggering reality straight from the World Health Organization, and it really sets the life or death stakes for what we're talking about today. We're always worrying about the hazards we can see, right? But honestly, it's the invisible ones quietly doing the most damage globally.
So, what exactly are we breathing? That's the million-dollar question here. If the air around us is really this deadly, we've got to figure out what invisible chemical and particulate invaders are actually in there. Because, spoiler alert, it's not just generic smog. It is a very specific, toxic cocktail. All right, here's our roadmap for this explainer. 1. The invisible urban threat. 2. Ground Zero, Lagos metropolis. 3. The pollution hotspots. 4. Decoding the AQI. 5. Predicting pollution with AI. And finally, 6. The future of clean air. Let's get into it.
Section 1. The invisible urban threat. Let's start by identifying the actual culprits destroying our air quality and human health.
Okay, so the crucial point is understanding particulate matter. PM 2.5 and PM 10 refer to suspended airborne particles that are insanely tiny. We're talking 2.5 and 10 micrometers or less in diameter. To put that in perspective, that's way smaller than a single strand of human hair. And that is exactly why they're so dangerous. They bypass our body's natural filters, shoot deep into our lungs, and can even cross right over into our bloodstream, worsening some pretty serious cardiorespiratory diseases. Alongside those particulates, we've got a whole squad of toxic gases, or as I like to call them, the chemical invaders. First up is carbon monoxide. It's colorless, odorless, and literally starves your brain and heart of oxygen. Then you've got sulfur dioxide and nitrogen dioxide, massive respiratory irritants pumped straight out of vehicle exhausts in industrial plants. Oh, and don't forget ground-level ozone. It's a nasty, transient contaminant that wreaks havoc on both human health and plant life. Section 2. Ground Zero, Lagos metropolis. To see what this actually looks like on the ground, we're zooming in on a massive environmental study out of Lagos, Nigeria.
Lagos is this incredibly vibrant, densely populated coastal megacity, right? Researchers went in and meticulously tracked pollutant data across 21 distinct zones. They didn't just check one type of area. They sampled quiet residential neighborhoods, massive open-burning dump sites, heavy industrial zones, and crazy busy traffic intersections. Basically, they wanted a full 360-degree picture of the city's atmospheric health.
Section 3. The pollution hotspots. And man, the data from those 21 zones paints a pretty stark, highly localized picture of where the threat is worst. The contrast within just this one city is absolutely staggering. On one hand, you have quiet residential estates, like VGC on Lagos Island, breathing in perfectly safe, very good quality air. But then, just a few miles away at major traffic intersections, the air was heavily degraded and highly toxic. Literally a tale of two cities. Let's look at the actual numbers here. At the Ashodi traffic intersection, researchers recorded carbon monoxide levels spiking to 42 parts per million. To give you some context, that wildly exceeds the US national standard, which maxes out at 35 parts per million for a 1-hour exposure. At these major bottlenecks, you've got thousands of idling cars just pumping out extreme levels of CO, actively binding to the hemoglobin of people nearby and literally starving their brains of oxygen in real time. And then there's the suspended particulate matter. Check out the industrial area of Ikorodu. It generates massive clouds of this stuff, hitting almost 4.8 parts per million. That completely dwarfs the measurements from the other zones. Why? Well, it's a brutal combination of heavy emissions from industrial machinery mixed with wind-blown dust from unpaved roads, a perfect storm for dirty air. Section 4. Decoding the AQI. Okay, so we have all these complicated chemical measurements. PM 2.5, CO, NO2. How do environmental scientists actually communicate this danger to the public? Enter the Air Quality Index, or AQI. The AQI is a standard warning system used globally. The scale tops out at 500. 0 means the air is pristine, but as you climb up to 500, that signifies the most severe, highly hazardous atmospheric conditions imaginable.
When that number goes up, public health takes a serious nosedive.
Section 5. Predicting pollution with AI. Knowing today's AQI is great, but what if we could see the future? Researchers in the Coimbatore region of India are using artificial intelligence to predict tomorrow's AQI before the danger even arrives.
This is where things get really cool. Scientists are using an artificial neural network, or ANN. Basically, it's a machine learning model inspired by the human brain. It gobbles up massive amounts of historical pollution data, processes it through multiple layers, and spits out highly accurate forecasts of future pollution levels. It is basically a crystal ball for air quality.
So here's exactly how the pipeline works. First, they collect hourly pollutant data from continuous monitoring stations. Then, and this is key, they pre-process that data using min-max normalization. That just ensures no single weird spike in one pollutant throws off the whole system. Next, they train the model using something called the Liebenberg-Marquardt algorithm. This algorithm is incredibly good at learning from past environmental conditions and untangling super complex chemical interactions to give us a precise real-time early warning system. And you know what the neural network conferred? Something fascinating. Using a statistical ANOVA analysis, it found that out of all the variables, the gases, the weather, our old friends PM 2.5 and PM 10 were the absolute strongest indicators of overall air quality degradation. So the exact same microscopic particles wreaking havoc on lungs and Legos are the primary drivers of the AI's predictive models over in India. It all connects.
Section 6, the future of clean air. We've seen the brutal reality of pollution on the streets of Lagos and the digital safety net being built in India. So how do we actually move forward from here? Here's what you should really take away from all this. We need a hybrid approach, combining old-school analog policy with cutting-edge digital innovation. We're talking strict vehicle emission management to clean up those toxic intersections. We absolutely have to stop the open burning of waste. We need to aggressively shift toward renewable, clean energy. And we need to implement these affordable, real-time AI prediction models globally, so governments actually have the data they need to protect people before a crisis hits. Which leaves us with one final vital question. Technology has finally reached the point where an algorithm can accurately warn us when the air is about to become toxic. But an algorithm can only predict the danger. It cannot prevent it. Ultimately, only human action and robust policy changes can clear the skies. The data is in, the predictions are dead on. The question is, what are we going to do with them? Thank you so much for joining me for this explainer. Keep learning and stay curious.